So in this question, we're being asked to both name the type of intermolecular forces at play and rank the relative boiling points of each of the 5 molecules. So let's start by looking for the types of forces. In this first molecule here, we're going to have primarily hydrogen bonding. And the reason for that is due to these OH groups, which are both donors and acceptors. In molecule 2, this is entirely non-polar. Therefore, we're going to have London dispersion forces being the primary intermolecular force. In molecule 3, we're going to have hydrogen bonding, as well as we have an OH group here. In molecule 4, again, we have non-polar. This will be London dispersion forces. And in molecule 5, we're going to have hydrogen bonding, where we have 2 different frameworks here. We have the donor here and the acceptor here. So we've got 3 examples with hydrogen bonding and 2 examples with London dispersion forces. Now we know that the examples with London dispersion forces should have the weakest intermolecular forces and therefore should have the lowest boiling points. So now we need to decide, will it be molecule 4 with its branching, or molecule 2 with less branching that has the lower boiling point? And molecule 4 will have the lowest boiling point because it has the most branching and therefore the most difficult way for the molecules to interact with each other and therefore the lowest boiling point. Molecule 2 is next. We then need to decide between the 3 types of hydrogen bonding molecules. Now, molecule 1 had 2 OH groups, 2 donors and 2 acceptors. Molecule 3 had a single donor and a single acceptor, the single OH group. And molecule 5 has both a donor in the OH and an acceptor in the carbonyl. And it's for this reason that molecule 3 will have the lowest boiling point of all the hydrogen bonding networks, followed by molecule 5, and molecule 1 will be up top with the highest boiling point for the most hydrogen bonding and therefore the strongest intermolecular interactions. So 4, 2, 3, 5, 1, entirely dictated by the type of force and then the magnitude of. How many donors and acceptors are there in the hydrogen bonding network and how much branching exists in the London dispersion examples.